From the library of the New York Stock Exchange at the corner of Wall and Broad Streets in New York City, you're inside the Ice House, our podcast from Intercontinental Exchange on markets, leadership, and vision in global business. The dream drivers that have made the NYSE an indispensable institution of global growth for over 225 years. Each week, we feature stories of those who hatch plans, create jobs, and harness the engine of capitalism. Right here, right now at the NYSE and at ICE's 12 exchanges and 6 clearinghouses around the world. And now welcome inside the Ice House. Here's your host, Josh King of Intercontinental Exchange.
Welcome back to the library. In the last few weeks, we've heard from Eli Lilly's Christy Shaw and Johnson & Johnson's Melinda Richter about some of the amazing developments in molecular biology and digital healthcare that are improving the quality of life across the globe. Scientific breakthroughs depend on the development and deployment of accurate, cutting-edge tools, and one of the companies that laboratories across the globe turn to for testing solutions is QIAGEN. That's NYSE ticker symbol QGEN, which is also part of the NYSE ARCA Biotechnology Index. QIAGEN was founded in the nascent days of molecular research to produce what its co-founder Metin Colpin called the pick and shovels needed to isolate the DNA that university scientists needed for their research. Today, laboratories process 50,000 molecular samples with QIAGEN products every day, and the company's solutions are cited in 19,000 scientific publications each year. QIAGEN's diagnostic tests have also played important roles in infectious diseases control, cancer prevention, personalized medicine, and more. Our conversation with QIAGEN's CEO Per Schatz on the molecular revolution and creating the tools scientists will need to find the next frontier of research. That's right after this.
Cushman & Wakefield is one of the premier brands in the commercial real estate services space. We have 48,000 professionals around the world in 400 offices in 70 countries. This company, 101 years old, if you can imagine, it's never been public. There's a reason they call the NYSE the big board. It's a great home for companies like us, big companies with big ideas. Cushman & Wakefield, now listed on the NYSE.
Our guest today, Per Schatz, joined QIAGEN in 1993 as its CFO. He guided QIAGEN through a 1996 initial public offering and was named its CEO in 2004. Under his leadership, QIAGEN has grown to employ 5,000 people around the world, generating annual revenues of more than $1.4 billion. Previously, Per served in various roles at Sandoz, now part of Novartis, NYSE ticker symbol NVS. And he helped found startup companies in the computer and software trading industry in both Europe and the United States. Per Schatz, welcome to the Ice House.
Hello.
So this is the end of the year. You'll be back tomorrow morning to ring the opening bell. Have you ever rang the opening bell at the stock exchange?
No, not yet. I'm looking forward to it.
And also hold a board meeting. How many board meetings do you hold each year?
About 5 board meetings.
So this is that wrap-up meeting when you sort of look to see how you did in 2018 and maybe look ahead toward 2019. If I was one of your board members around the table, what would you say about this year and looking ahead?
Well, we're very pleased with the performance in 2018. It was a very good year. First of all, we had very solid financial performance, exceeded our targets, but we're also showing accelerating sales and earnings growth, and that well into the future. On top of that, we were able to add some very fantastic strategic momentum to the company in terms of new growth opportunities, new products, new innovation. So the future looks bright. Indeed, it is one of those board meetings where we can look back at a good year, but even more importantly, look forward to what we think is going to be an even better year, 2019.
What about 2019 holds particular promise? Are there changes in the laboratories, changes in the regulatory landscape, changes in terms of trade for a company like yours? If you think about when the clock strikes midnight on December 31st and you're into a brand new year, what makes you optimistic?
Well, the company is performing very well across its different customer classes. We're a highly focused company on technologies and tools that are used to take a sample through to creating an insight from that sample, where the molecular content, the information contained in the DNA and the RNA, can be used for clinical decision-making or increasing the knowledge base that we have in research. This is such a fundamental area of research and clinical use and is growing at a very good growth rate going forward, and we're very proud to be able to fuel it using our technologies and tools.
So QIAGEN has grown, Per, and evolved as science has gone through this unprecedented period of molecular biology breakthroughs. And science labs today depend as much on pipettes and samples as backroom data centers to process the findings and store genomic data. What impact has big data had on biology?
I think there are two trends. So first of all, we are seeing new tools emerge that are creating a lot more data from samples. So we can generate more information from DNA and RNA samples than we ever have been able to do, and the curve going forward is even more steep. On top of that are now being able to enjoy increasing capabilities to integrate multiple data streams for analysis. So we can take different sources of information, pool them, and then use advanced data analysis and interpretation tools to identify insights that could be relevant for research or also clinical purposes. We're creating enormous amounts of data in biology and actually experiencing exponential increases in data generation. In fact, more data is being generated in biology in the last 6 months than in the history of mankind before. So exponential increases of data generation. And a lot of these cloud-based infrastructures today are to a very significant degree being utilized by data generation, in particular in genomics.
In September, Per, an article from Insight magazine published on your website proposed how artificial intelligence, machine learning, and the Internet of Things will be integrated into hospitals. How are healthcare providers already utilizing molecular diagnostics to improve their treatment of patients, and what do you expect will be possible, going forward, looking ahead to like 2025?
Well, molecular diagnostics is really a very young technology. It really started in 1983 with a scientific advancement that received the Nobel Prize a few years later. And today it is pretty widely available. That's quite remarkable that such a fundamental breakthrough technology has achieved such a very large status, created a very large industry. We're talking about a $5-6 billion industry in this short period of time, but it has really just started. It has become so robust and at the same time increasingly powerful. I'll give you an example. Today, if a mother or father has a child with high fever, a runny nose, traditionally one went to the physician and received antibiotics, which very often were misguided. Today, using a new and powerful technology from QIAGEN, within an hour, a genetic molecular analysis can be done, scanning for dozens of bacteria or viruses to identify the appropriate treatment for the child. This is a tremendous breakthrough that not only will provide better health care to the patient, but also can help us avoid what is today over 50,000 casualties due to antibiotic resistances. We are using tools like that to generate data, but more importantly, we are integrating the data from all these sources, and that is really just starting. The healthcare industry is not yet used to tools that are pooling data. We have created, for instance, very powerful tools for genomic data. We are by far the market leader for that. And these tools are, in the meantime, considered standards in the area of genetics and oncology. So when modern information generation tools are used to sequence DNA in genetics and oncology, our cloud-based infrastructures come into play and help physicians and also researchers analyze and interpret that data. These are true game changers in terms of being able to interpret masses of data, and this is just the beginning.
Another game changer I discovered just surfing through your website, Per. Most corporate websites have a bunch of different screens that you could tell different stories about the company, and I'm flipping through them, and many of them are dealing with the issues that we've just been talking about already. And then on this last screen, it was QIAGEN, something like helping get closer to justice for people. And I said, well, what does that really mean? And I clicked on it, and I opened up, and it said, our tools and our data and our capabilities will help law enforcement and others who want better DNA samples as they investigate crimes and sometimes if there's insufficient DNA or it's not a clean sample, you've got breakthroughs in that area as well.
Absolutely. So DNA testing technology is, in the meantime, a standard tool in what is called forensics. We are very proud to be working with laboratories around the world. I'll actually be visiting some customers in this field here in New York tomorrow. The process is very similar to analyzing the DNA of, for instance, a tumor, or even searching for the DNA of a virus in a blood sample. These tools are increasingly powerful, and they are becoming more standard also in today's forensic use. Using these more and more powerful technologies, many of the forensic scientists can go back and revisit cases that had led to a conviction many years ago, retest the samples, as we now can extract even more minute amounts of DNA from, let's say, crime scene samples. And we also have better resolutions in the way we test that DNA. Many of these old convictions can actually be overturned because the forensic evidence can prove that the suspect or the initially convicted individual is innocent. So these are incredibly emotional examples of the power of these new technologies. And we are today present in almost every police laboratory around the world. It is a very challenging science because the samples are degraded and often very difficult to test, and therefore an area where we are very proud to contribute also the most advanced technologies, very often before they move into other segments.
This year's Nobel Prize in Medicine was awarded last month in a field where QIAGEN's sequencing solutions play a major role. Let's hear from PBS's Nick Schifrin.
For years, cancer treatment was dominated by 4 techniques: surgery, radiation, chemotherapy, and hormone treatments. There is now a 5th category because researchers overcame a fundamental challenge. In the past, they couldn't recruit the body's own immune system to fight cancer. But today, they can. And that is thanks to the research of Jim Allison, today's Nobel Prize winner and chairman of immunology at the University of Texas MD Anderson Cancer Center.
Using the body's own immune system in the fight against cancer, can you explain how companion and complementary diagnostics assisted the work of Jim Allison and his colleagues who shared the Nobel Prize with from concept to solutions?
Well, the 2018 Nobel Prize is a great recognition of great science that is also changing healthcare as we speak. The prize recognized major contributions to the field of immuno-oncology, and this is really changing the way how cancer is being treated today. We are extremely active in this field, not only supporting researchers like these 2 Nobel Prize winners with the tools that they can employ to generate their innovation and advance the sciences in this space, but we're also creating new diagnostic tools to ensure that these powerful new drugs that are being developed by pharmaceutical and biotech companies around the world can be used on the right patients, in the right doses, and at the right time. For that, very complex genetic tests need to be performed on these patients, and we've partnered with many pharmaceutical companies to create such tests that are tailored to their drugs. Now, let me share a secret with you. Every fall, every October, when we know that the Nobel Prizes are about to be awarded, there's a very special thing that happens at QIAGEN. You suddenly see 5,000 employees basically waiting for the news to cross the wires who has won the Nobel Prize. And what we do is we immediately then search the web and try to find pictures or references where the science that was recognized with such a tremendous prize was contributed to using QIAGEN products, and we are extremely proud. This is not something we share publicly. This is something we celebrate internally, that every year we see a tremendous role that QIAGEN has been able to play in the laboratories of these Nobel Prize winners that really stand for the 500,000 other scientists around the world that are working so incredibly hard to advance the sciences and improve our everyday lives. And this is something most gratifying for us at QIAGEN.
Talking about the collaboration that you engage in with scientists around the world, in order to develop the tools that researchers need to find the next breakthrough, your company works closely with laboratories on every corner of the planet. How are you organized to do this?
Well, what is extremely important is to be very close to customers in the academic sciences, in pharmaceutical companies, but then as the technology also goes into routine testing, for instance, in hospitals and clinical laboratories around the world. The reason, therefore, is that this science is moving at an incredible speed, and our customers are at the forefront of science and clinical decision-making using these new technologies. And so the feedback loop into our own innovation centers to help develop the next generation products for them is incredibly important. We pride ourselves to not only supply researchers in academia, but also help translate that innovation that they contribute to into clinical decision tools, diagnostic products that are used in routine settings. We pioneered many advancements in this area. The 2008 Nobel Prize was awarded for the use of HPV as a marker, as an early risk marker for cervical cancer. We were the company that pioneered this form of testing, and hundreds of millions of women around the world are now benefiting from this technology. We're doing something similar in tuberculosis today, one of the biggest killers known to mankind. And we were the pioneer in the area of personalized medicine, creating new tests that pair up with these next generation drugs to improve outcomes for patients around the world. So this close proximity to customers in research and also in clinical decision-making has been incredibly rewarding and important for us.
We were talking before we started our conversation about where your board members hail from, one from New York, several from Boston, a few from Germany. Mentioned also the 5,000 employees of QIAGEN. How are you dispersed around the world, and what's the strategy behind where you locate your people?
Well, we've always been very careful not to be a company that has a strong headquarter and many satellites. Science is an incredibly global field. If a researcher in, let's say here in New York, reads academic literature, it doesn't really matter if the scientists are from China or from Korea or from Latin America or from Europe. If the science is good, it will be very worthwhile reading. And this is the approach we also take as a company. We're an extremely global company. We're organized under a Dutch holding company with strong sites in Germany and in the United States and in China, but always consider ourselves global citizens, and from that perspective have valued that diversity that brings to the company.
You mentioned just prior in our conversation this disease that we thought has been with us for centuries and in many ways was managed or understood as much as we could. That's tuberculosis. But sometimes we need new breakthroughs for old diseases, and TB has had a resurgence back into the top 10 deadliest diseases and has become increasingly resistant. What forms of testing does QIAGEN offer to help researchers understand how the disease manifests itself and how to fight it in new ways against these new strains?
Well, you're absolutely right. TB is one of the biggest killers known to mankind still today. A third of the world's population is infected with the TB bacterium, and most of them obviously don't know it. The problem in battling tuberculosis is that it takes two forms. By far the majority of the TB-infected population, over 99%, is what is called latent infected. They are not symptomatic, but they carry the bacterium, and it can flare up into the active form of the disease. In other words, where the symptoms show, coughing and other symptoms TB is known for. And in the active phase, patients are highly contagious. So the goal is therefore to detect and to treat them while they're still in the latent phase. And one of our biggest areas of growth is a new test called QuantiFERON TB that does exactly that and has just started to replace an over 100-year-old cumbersome and highly unreliable testing approach. QuantiFERON TB is a simple blood test that allows a highly accurate detection of latent TB and thereby allows patients with latent TB to be detected early and treated, and exactly what we need to stop the spread of TB and possibly even eradicate it.
What's the process by which QuantiFERON TB is developed as a testing protocol for QIAGEN?
Well, QuantiFERON is a platform technology, as it is called. It is a very intriguing approach in which we query the body's immune system as to ever having seen a certain phenomenon. So by challenging the immune system's cells with information that is specific to tuberculosis, we can ask these cells that share the information among each other, by the way, if any one of them has ever seen such a phenomenon, and if they react to this stimulus, we know that there is a latent TB infection. It sounds incredibly challenging, but we've been able to put it into a very robust form that actually can be used around the world, even in resource-poor settings.
And so what are some of the results once it's employed?
So if a patient is latent tuberculosis infected, they are not contagious. They are highly treatable. There are treatment regimens that they can be put on that are inexpensive and that can eradicate the latent infection. Again, this is not a disease that is confined to poor areas of the world. There are areas, probably even here in New York, where you will see 20 to 30% of people actually latently infected. And there are active TB flare-ups constantly, also in cities like New York, very often in settings where people are in hospitals and under treatment for instance, cancer or other infectious diseases. And in that stage, they're obviously highly contagious and can infect other people. In particular, this is dangerous in hospitals when the other people are sick and need their immune system strength to recover.
After the break, Per Schatz and I talk about how QIAGEN has developed over the last quarter century and how its sample-to-insight strategy guides its growth. That's right after this.
Arlo's a next-generation smart home company that provides a super simple do-it-yourself home security solution with up to 48% market share and class-leading internet technology. We're looking at new products and even grow internationally. The NYSE obviously has a tremendous history. The way that they actually bring the stock to market, there was a human element that stabilizes the market. And you can see that in the stock opening today. Having a strong partnership to actually bring Arlo as a public company was really important to us. You only get to do this once.
Welcome back. Our guest inside the Ice House today is Per Schatz, CEO of QIAGEN. Before the break, we were discussing how molecular biology is changing the world of healthcare. In particular, we were drilling into the quantiferon TB, QIAGEN's approach now to helping address the scourge of tuberculosis. Per, you joined QIAGEN in 1993 as its CFO. How had the company grown from its founding, and what were the first few years of your time with the company like?
I think CFO is a big word for a company of 30 employees. But
just 30, so you've got a lot of finances to look after 30
right.
people.
So basically a company that size, everybody does everything. And, this was a really interesting time for us because the company was started in Germany and spun out of a university. And as we all know, Germany at that time was not really known for startups, and it was a very difficult startup environment that we started out in. And actually the total financing prior to going public was $5 million, just to compare that with some of the ABC round financings that you'll see with many startups here in the United States. The company was spun out of a university, was very scientific.
Which university was it?
It was University of Düsseldorf. Mm-hmm. And it was a very mixed bag of activities. And what happened was that we took one piece of that and formed QIAGEN, what it is today, focused on the tools that were used back then to support the laboratory work of that initial startup, and that became the primary focus then going forward. And that unleashed considerable growth in the 90s as the DNA testing technology started to emerge, and our tools rapidly became the standard around the world. That was also obviously supported by the further financings that we were able to get in when we went public.
So let's track some of those years in the 90s from employee number 31 to call it employee number 1,000. In the 90s, QIAGEN began to diversify from just processing kits into spaces like molecular diagnostics. What principles guided your growth and acquisition strategy if you think back to those years, in the 90s and early aughts?
So one of the elements of our DNA, of our company's DNA that we're all quite proud of is the strategic agility that we have. And we've seen that in the history of the company a few times. So we started out in the early days of this DNA revolution, supplying kits to researchers, dramatically improving the way DNA can be processed. What we then added to the core capability was the ability to also to automate those technologies. And that's where most of our competitors or peers or the early startup companies in this area basically failed. They continued to sell the kits. Our customers wanted to have higher degree of throughput, easier processing of these samples, and Kaijin was one of the few companies that made that shift into not only good chemistry and biology, but also being able to automate it. We then took one step further and followed our customers as they moved out of the research laboratories into pharmaceutical companies, into police laboratories, into the clinical world. And as we followed them, our products that immediately adapted to the needs in that space. And the clinical segment was basically created 15 years ago, 20 years ago, and today is our largest individual customer class.
Your core business of testing goes across several disciplines, from some of which we've discussed already. They include things like veterinary medicine, food and public safety. We talked about before the break that every 15 seconds a crime in the United States is investigated using one of your forensic products. With all these things in your portfolio, what are the areas you expect to see the biggest areas of growth over the next few years?
Well, the technology that we are helping develop and also contributing to in terms of the scientific progress is so dynamic. As I described before, the data that is being produced today is in 6 months going to exceed what has been created in the history of mankind before. So a tremendous exponential growth of data, and the science is just with that increasing amount of data becoming ever more sophisticated. So we will be able to do more and more things going forward. If I look near term at what we are doing at QIAGEN, one of the most exciting things is what you referred to before, our position in immuno-oncology. We have an extremely strong position in partnering with pharmaceutical companies to develop diagnostics for their next generation drugs, or the partner of choice. We've partnered with more than 25 companies in a very large master collaboration agreement, dozens of programs going on at any given time. And a lot of them are now in the area of immuno-oncology. And the power of that technology and our ability to contribute to that technology becoming more widely employed and even more effective is not only very gratifying, but an area where we're very proud to see the speed of the innovation also come to patients.
Toward the end of the last U.S. presidential administration, you saw a major announcement with President Barack Obama appointing his vice president, Joe Biden, whose son died of a brain tumor, to lead what was then called, and I think Vice President Biden still thinks of it as the cancer moonshot. Are you seeing a leveling off or a continuation among global governments of being a partner and a supporter and investor of more and more cancer research, the types of which that you can help enable?
Absolutely. And I had the opportunity to meet with Joe Biden and extremely impressed by his vision and also his commitment to this space. We've also seen very strong commitments here, in particular in the United States. A remarkable job being done here by the National Institutes of Health, driving research forward and also creating areas of focus and emphases. This is a challenge that we will only be able to meet if we work together on a global basis. And science is such a tremendously global community. Scientific conferences are, per definition, typically global, and research does not know borders. And this is, I think, a great testament to the power of working together in global teams. Even though there is a lot of competition in science, it is driving innovation at a breakneck speed, also due to the fact that it can work in these global networks.
Research does not know borders. As we said earlier, you've got 5,000 employees across 35 subsidiaries that serve a variety of research and healthcare fields. If there's something that drives QIAGEN in particular, we've talked about sample to insight, or we've mentioned it. How does that philosophy help the company to stay in alignment?
I think sample to insight, which is a core philosophy at QIAGEN and also our tagline, is a great example of the strategic agility that the company has shown. In technology-centric companies, which most startups in the technology fields are, it is very difficult to pivot into a customer-centric approach. And that is incredibly important as industries evolve and customers are demanding not only the first wave of information, but the second and the third and the fourth. Be it in product innovation, be it in our commercial discussions with customers, it is key for everybody at QIAGEN to understand first what the customer is considering and what information and insights they want to be able to achieve, And then we go back and position our workflows and our market and technology leading components in a way that the focal point of our solutions and our discussions will always be the value proposition of the insight that the customer is looking for. It's about the information they need for their scientific advancement and clinical decision making. And ultimately, the technology is simply enabling them to get there.
As you're talking about customer insight and listening to the customer, what form does that take? Is that you and your colleagues going into their offices and having conversations, spending time in their labs? Are you using more sophisticated or more technological means of data gathering about things they're doing and taking immediate feedback? And what's the feedback loop for QIAGEN with your customers?
Well, I think the most important element of that is a cultural openness to listening and always having a certain degree of humility in terms of what is important. A priority will come from the customer. And I think that's something we've been able to achieve. Of course, there are elements of that that are shown by the fact that I, for instance, try to spend about at least 20% of my time a day a week with customers. And this scales into most areas of the company. And that interaction is so incredibly important to bring innovation that they generate every day. And again, we're talking about scientists, and their business is innovation and sharing ideas. And we can benefit tremendously together with our customers from that exchange. And that's something that we celebrate and that we also value tremendously. At the same time, obviously, there are so many people in this field, so we can't interact personally with everybody. And a few years ago, we've transitioned the company into what we designed to become the leader in our space in terms of digital capabilities. And we're quite proud of the position that we've created today. We were elected 2 weeks ago the #1 most advanced digital enabled company in Germany, and this is just one of the examples where we participated in one of these contests. But we see digitization as a capability to scale a company, to achieve economy of scale for a company our size and compete with even much larger companies. The customer interactions, the ability to interpret that information that they're sharing with us using advanced digital tools is something that we've become very good at, and that is helping drive our innovation and also guide our commercial teams.
What form does digitization and digital enablement take shape at QIAGEN?
Well, we believe that digitization is a fundamental revolution, just like molecular biology is, and we're applying it across all of the elements of our workflow. So the value chain starts with innovation, so we are mining new trends from scientific literature and other sources to identify new and emerging approaches, scientific workflows that potentially could be better enabled using technologies that we could make available. So even the earliest stage innovation is enabled using digital technologies, harnessing big data, public and private data sources, and interpreting them very often using artificial intelligence, through to the manufacturing where the quality control, the optimization of the workflows, is the optimization of the supply chains is heavily enabled using digitization. And then into the administrative areas where our company relies extremely heavily on digital back office infrastructure that allows us to ensure that our resources, our employees are actually customer and innovation fronting, and that the back offices are dealt with as efficiently as possible, down to the interactions with customers where we try to understand and to log these interactions with customers in a way that we don't waste their time with information that might not be necessary for them, and can ensure that every interaction with our customers will help them create better insights and ultimately therefore make them more successful.
As we wrap up, can you highlight some of the research projects underway at QIAGEN or with your equipment that you think will have the biggest impact on our day-to-day lives as we look forward not only to 2019 and what you'll be talking to your board about tomorrow, but into 2020 and beyond?
We mentioned two. We talked about our position in next-generation sequencing and immuno-oncology. We have a very attractive new franchise emerging there. We talked about tuberculosis. I talked very briefly about this example of this very robust yet compact and easy to deploy molecular tests using the example of the child with a fever and the running nose, so we can resolve these very complex infections in children. We also have a new system that is highly disruptive in centralized labs that will allow tests to be run in 40 minutes that previously took 3.5 hours to run using modern genetic analysis. And this is a multi-billion-dollar market. So we are addressing today multi-billion-dollar markets with disruptive new tools on the foundation of the history of QIAGEN over the last 20 years that has created this enormous recognition in molecular biology for quality, for reproducibility, and innovation. And we're now unfolding what we think is probably going to be one of the most exciting growth phases of the company over the next few years.
I hope your board gets that message loud and clear when you meet with them tomorrow.
I'm sure they will.
And your investors certainly have, based on the performance of the company. And thank you for spending a few minutes with us in the Ice House to help our listeners understand it as well.
Thanks for hosting me.
That's our conversation for this week. Our guest was Per Schatz, CEO of QIAGEN. If you like what you heard, please rate us on iTunes so other folks know where to find us. And if you've got a comment or a question you'd like one of our experts to tackle on a future show, email us at icehouse@theice.com or tweet at us at NYSE. Our show is produced by Pete Ash and Ian Wolfe with production assistance from Ken Abel and Stephen Portner. Some portions of the preceding conversation may have been edited for the purposes of length or clarity. I'm Josh King signing off from the Library of the New York Stock Exchange. Thanks for listening. Talk to you next week.
Information contained in this podcast was obtained in part from publicly available sources and not independently verified. Neither ICE nor its affiliates make any representations or warranties, express or implied, as to the accuracy or completeness of the information and do not sponsor, approve, or endorse any of the content herein, all of which is presented solely for informational and educational purposes. Nothing herein constitutes an offer to sell, a solicitation of an offer to buy any security, or a recommendation of any security or trading practice. Some portions of the preceding conversation may have been edited for the purpose of length or clarity.